Another special right triangle situation occurs when we have what is called a 30, 60, 90. This one is a little bit harder to see. It's not as common sense as the 45, 45, 90, but it's still a recognized situation. So again, we have a 90-degree angle. This is probably 30 degrees here, which makes this guy equal to 60. So 30 degrees and 60 degrees equals 90, plus that other 90 gives me my 180. So we'll always have that relationship 30, 60, 90. And one of the things you can already kind of get a feel for is that this angle, right, is if we double it, we get that angle. So one of my sides has to be 2 times another side. And it turns out that the side that does that is the hypotenuse. Okay? What side is it double of? It's going to be this side right there. In a 30, 60, 90 situation, the side that is opposite the 30-degree angle, that's the most important side of all because that determines everybody else. So it turns out that this side would be 2 times 4. It would be 8. And then this is going to get a little more complicated, but this side down here is going to be 4 times the square root of 3. All right, so how can we prove this relationship to be true? Well, again, we know that the Pythagorean theorem is true, so let's put our information in there. So here's A, here's B, and here's C. And so our A in this case is 4, our B is 4 square roots of 3, and our C is 8. So if this relationship amongst the sides is true, this should be a true statement. So 4 squared is 16. Here we are squaring a product, so 4 squared is 16. The square root of 3 squared is 3. And then over here we get 64. And this is 16, this will be a 48. And then of course 16 plus 48 is in fact 64. So that relationship I told you is true. So in a formula-wise, right, pattern-wise, here's what we've got. So if this is the 30-degree angle, the side opposite is going to be x. All right, so that's the side that determines everybody else. The hypotenuse will always be double that x value, and the base b, or this long side here, would be whatever x is times the square root of 3. All right, and there's your proof that that works already. I'm not going to go with all the x's. So there's basically our pattern. And so it's all about finding what x is, right? So either we're given it straight out or we can find it with some other relationship. So let's get to work. So in the first example, what I have is a 30-degree angle here, which makes that 60. And we're given the length of the hypotenuse. Okay, so we know this side has to be x, this side has to be x squared of 3, and this side over here has to be 2x. And so essentially what we have then is 2x has to be 24. And so if we divide both sides by 2, we get that x is 8. So this side would have to be 8, and this side would have to be 8 square roots of 3 based off of the pattern that we have. So I'm able to not use the Pythagorean theorem, just make use of the pattern. Again, this would be in feet, and this would be in feet because of the units that are given. So there you go. All right, so looking at the next one, again, we have a 60-degree angle, so that means that's 30 degrees. So the side opposite of the 30-degree angle, that has to be x, that has to be double x, and this has to be x times the square root of 3. So the side we're given is that. We're given the square root of 48. So if we simplify that, I believe 48 is 16 times 3. Right, we kind of saw that up here. So this is 4 square roots of 3. And so that means that our x is equal to 4. So that makes this side 4, and it makes that side 8, and that would be centimeters and centimeters. So kind of a redux of what I had up there. All right. Continuing on, we have a 60-degree angle here, which makes this the 30-degree angle. Again, the side opposite the 30-degree angle is always x. That's double x, and that's x square roots of, dang, why do I keep doing that? X square roots of 3. So we know right away that x is 7. So that means this side has to be 14, and this side has to be 7 square roots of 3. And this would be measured, I didn't put any units on that one, so it's be units right now. So there you have it. So we're making use of a pattern, 30, 60, 90 pattern, or a 45, 45, 90 pattern to basically find the lengths of my other two sides. Alright, we'll practice this a little bit more in one more video.